Like so?
Yeah.
Okay, groovy. And what was your nugget? Cost of 100 is 25,000. All right. So how can I rewrite that nugget so that it makes sense in math terms? When x equals what? 100. What's cost going to equal? 25,000. Okay. So it wants us to find the total cost function, right? So what are we going to do? Good morning, Chandler. You don't have to be all the way back there unless you want to be. You're good? Are you sure?
So you take the integral of the marginal cost?
Yeah, you're going to integrate marginal cost. And Marie, I think you said that as well, right?
Mm-hmm.
Okay, groovy. All right, so let's integrate it. So cost is the integral of 140 plus 0.15 square root of x with respect to x, right? Is this integral 1, 2, 3, or 4? It's 1, isn't it? So let me rewrite this. Cost equals the integral of 140 plus 0.15 x to the 1/2, right? And this is with respect to x. So once I've made it pretty, it's pretty clear that this is integral number 1 because we don't have a function times a function, we don't have an e, we don't have a -1 anywhere in here as an exponent, so it can't be integral number 4. We're working off of integral number 1. So what's my integral, guys? 140x, good, plus 0.15x to the 3/2 over 3/2, plus some constant associated with cost. Well, that's some messy stuff, man. All right, so what's 0.15 times 2? 0.3? And what's 0.3 divided by 3? 0.1. So I'm going to rewrite this as cost equals 140x plus 0.1 x to the 3/2 plus k sub c.
So is this the donut that you applied?
Uh-huh. Yep, I just inverted and multiplied. Or copied that from, I don't know, there's a whole bunch of ways to say it. Okay, groovy. So what do I do next?
Now you find for k.
Now I plug in my nugget and I use that to find k. That's right. Groovy. So I'm going to set c equal to 25,000. 1, 2, 3. And I'm going to set x equal to 100. So 140 times 100 plus 0.1 times 100 to the 3/2 plus k sub c. I have no idea what that is. It's 10. Is it, what was that? 10,000? So that's k sub c. Thank you very much, you guys. I'm like, I'm not doing that one in my head. It's not happening today. So what's my true cost function now?
It is the original.
It's going to be 140x plus 0.1 x to the 3/2 plus 10,900.
So whatever was c, you just plug, you just add the kc, which is 10,900.
Say that again, Maria?
So the cost function which we found out,
Yeah, after we integrated.
we add the kc, which was unknown at that time.
Right, so we use the nugget to find
complete
k
it.
sub c. And then we shove that back into the equation so that it's accounted for. Any questions about this one? What threw you guys off? The square root? Is that what did it? Every time. So remember, on your tattoo, the steps for integration, the first step is make it pretty. Get rid of radicals, get rid of x's on the denominator. So once you convert that sucker to a radical, do you see how easy it is to tell which integral it is? Before that, it's not as easy, at least to my eye. Okay? Any questions on this one before I erase it? You guys good? All right. Let's look at number 7. asked for 7? Nikki, was that you? You asked for 9. You asked for 9. Who asked for 7? Maria, was that you? Okay, is yours marginal cost equals 3x plus 20? And marginal revenue is 44 minus 5x?
Possibly. Yes.
Okay, groovy. Okay. So we're given marginal cost equals 3x plus 20. And we're given marginal revenue equals 44 minus 5x. And the cost of production of 80 units, cost of 80 units is $11,400. Okay. So here we are, we're given a marginal cost, a marginal revenue, and a nugget for cost. By the way, what's our nugget for revenue? 0, 0. Always, 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 always 0, 0, right? So part A says find the optimal level of production. So when I say optimal level, or when the book says optimal level of production, I want you to think like a business. What does optimal level of production mean? That's where your what is maximum. Profit. That's right, we're looking for an X value that maximizes profit. We don't care about anything else, right? We just want the money in the bank as a business. Okay, so maximizing profit. We are asked to find production level, and that's X, that maximizes profit. Remember that little trick I taught you guys last time? Profit equals revenue minus cost. Marginal profit equals marginal revenue minus marginal cost. Remember, the X value that maximizes profit is where the slope of profit equals 0. So we're gonna set marginal profit equal to 0. And we're literally gonna drag marginal cost over. So where marginal cost equals marginal revenue. Oh, shit. Thank you. You want the point? Take it. I forget, you're with a K, right?
Yep.
KH?
Yep.
Points for Christina. So now we're solving for X. Basically here, guys, we're delaying the inevitable because we know we're gonna have to find a profit function eventually anyway, but we can do a quick and dirty on marginal cost and marginal revenue and find that X value immediately. So I'm just gonna set 3X plus 20 equal to 44 minus 5X. So if I add X to both, or to 5X to both sides, I get 8X. I'm gonna subtract 20 equals 24. X, lo and behold, is 3. So that's the production level that maximizes profit. Any questions?
Just the marginal cost is equal to marginal revenue.
Yeah.
That kind of trips me.
Do you see how I got from step A
Yeah.
to step B?
Yes.
And step B to step C?
Yes.
And step C to step D? If I add marginal cost to both sides? I'll end up
Yes.
with
So you
marginal
just did
cost equals-
algebra. Okay.
Yeah, I just did algebra on this, yep. And a tiny bit of calculus
Thank you.
by whipping through and taking the derivative all the way through.
Thank you.
Mhm.
That helps.
Part B, find the profit function. See, now we actually have to find profit.
Wasn't this problem on the homework?
Yeah. That's why they're asking for it, remember?
Oh, right, I'm sorry. I'm
It's
thinking
okay.
about something else. Jeez.
Do you want what's left of my coffee, honey?
I'm okay,
You're
thank you.
okay? I'm right there with you. I'm already like 3 mistakes deep on the board. It's good times. Find profit function. All right, so how do we do that, guys? Can we build marginal profit and then integrate that?
No.
Why not? What do we need in order to integrate for application functions?
We need a regular profit, we don't have it.
We need a regular profit. We need, what was that, Christina? We need a constant. We need to be able to solve for K sub P. But do we have a nugget for profit? No.
Actually, we do. X is equal to 3.
What? No, that's an X value. Let me redraw this again. Really quick. Profit looks like this, guys. This, I heard that. I'm with you. This is the X value we found. This is X equals 3. Okay, we found that by literally setting the derivative marginal profit equal to 0. So if we want to get the corresponding maximum profit, we need to be able to shove this X into a profit function. So we have to build profit. And we have to do that by integrating revenue and cost. So let's start with revenue. Revenue is the integral of marginal revenue. Is this gonna be integral 1, 2, 3, or 4?
1.
Yeah. So that's what, 44x minus 5 halves x squared plus k sub r?
Mhm.
And how do I use my nugget?
You plug X into the X is equal to 3 into.
Yeah, so I'm gonna use 0 equals 44 times 0 minus, that's just too ugly to do, minus 5 halves times 0 squared plus k sub r. So what does my k sub r equal, guys?
0.
0. So now my real revenue function, I'll write it under here, is gonna be 44x minus 5 halves x squared. Now I need to do the same thing with cost. So cost is the integral of marginal cost, which was 3x plus 20, integral 1, 2, 3, or 4? Still 1. So 3 halves x squared plus 20x plus k sub c. And now I need to use my nugget. What do I plug in where? Into equal to. Good, Helena. Good. Equals 3 halves times 80 squared plus 20 times 80 plus k sub c. Let's see if I can do this in my head. 6,400 times, divided by 2 is 3,200 times 3 is 9,600. 9,600 plus, no, I'm not gonna do it in my head. Thank you. Thanks, Nikki. K sub c is 200. So now what's my real cost function, guys? Plus 20x minus, or plus 200. Very good. 1.5 said Helena, 3 halves, doesn't matter, guys, whatever floats your boat. Yep, they're both mathematically correct.
The 80 from, is it the 5 halves times 0 squared?
Which 80, this 80 right here?
Yeah.
Ah, it comes from the nugget itself. It said the cost of 80 units is 11,400, so I'm literally plugging this in for X and this in for C so that I can solve for my third unknown. Good. Yeah. All right, so now what do I do, guys? Revenue minus cost, and I think you can take it from here, right? Yep. Okay. What was the hardest part for this one? Anybody?
I think when I went to, before I got profit,
Mm-hmm.
I had 44x minus 5 upon 2x squared
Mm-hmm.
minus 3x squared upon 2 minus 20x minus 200, and trying to solve the fractions was giving me a problem. To get x is equal to 3. That's where I had the problem.
Up here?
Yeah.
She's talking about when she was doing the revenue minus cost
Revenue, yeah.
Here?
function. No, at the end, the next step of
Oh.
all
Yeah.
of that.
Oh, okay, so it's gonna be negative 5 halves minus 3 halves. They have the same denominator, so what's negative five
It's
minus
a-
3?
It's a plus, so, but it's going to
not
be a
gonna be plus.
negative. I mean, you're adding it, but you have the negative with it.
You're not adding, you're subtracting. It's revenue minus cost,
Oh, yes.
okay? So you're gonna be subtracting, so all the signs in your cost function are gonna change. So you'll have negative 5 halves x squared minus 3 halves x squared. That's gonna become negative 4 when all is said and done. Because negative 5 minus
Because
3
we
is
got
negative
8 upon 2, and then of course we
It
subtracted
would
it.
be
to
negative 8 over 2.
Yeah, so
Yeah.
in order to get that, we were struggling at the fraction point.
Okay. Does it make sense now?
Yeah.
Groovy. Okay, awesome. Any other questions on this one? All right. There's nothing new here, guys. Nothing you don't know how to do. Nothing at all. Now you're just taking the tools you've been given and you're combining them to build stuff you already know how to build. Okay. Number 9. So, did you ask for this one? Did you get marginal revenue is 900 and marginal cost is 30 square root of x plus 12? Okay. Okay. So we're given marginal revenue is 900. The marginal cost is 30 square root of x plus 4. We're also given a nugget. Fixed costs are $1,000. Okay. Find the profit or loss from production and sale of 5 units. So it wants you to find profit or loss from sale of 5 units. So in layman's terms, we're looking for profit at 5. Right? So what do we need?
So
We
you,
need revenue. We need cost. We need revenue minus cost. We need profit. So how do we do that?
we start with marginal cost, we make it pretty.
Sure. Let's do marginal cost first. What the hell? Marginal cost. No, that's not what I wanted to say. Total cost is the integral of 30 times the square root of x plus 4, which is 30 times the quantity x plus 4 to the 1/2 with respect to x. Is this integral 1, 2, 3, or 4? I
Still
heard
1.
I heard 2 and I heard 1. Who's with the 1s? Pitting you against each other now. Who's with the 2s? The 2s have it. Tell me why.
Because of the x plus 4.
What's the base of this exponent? Is it just an x or is it an entire function?
X plus 4.
It's an entire function, right? So when we have a function to a power times something else, that's essentially function, function, power. You guys with me? So function, function, power, and that power is not -1. This is by default integral number 2. In order for it to be integral number 1, your exponent up here has to be just a 1 so that you can peel all of this apart and integrate all the chunks.
So
Okay?
you're saying when we see a half as an exponent, it should remind us that it's integral number 2?
Well, I'm saying it ain't integral number 1.
Okay.
It could be
That's
also
a
be
good
integral
clue.
number 3,
Yes,
because you could have a half on a
Yeah.
3x, for example,
I
above
agree.
an e,
thank
and
you.
that would still give you integral number 3.
That's a good clue.
But it is not integral number 1, it's
Yeah.
not integral number 4. You can say that for sure,
Okay.
right?
Thank you.
Because there's no e, it can't be
Yeah.
integral number 3. Does that make sense?
Yes.
Okay, so my u here is x plus 4. I'm always gonna follow the steps, guys. My u prime is 1, what do I have? I have 30, what do I want? When do I want it? Now. So if I yank the 30 out, will there be a 1 waiting for me?
Yes.
Yeah. 30 integral 1 times x plus 4 to the, whoops, that wasn't ready for that. To the 1/2 with respect to x. This is going to be cost equals 30. Here's my u, here's my n plus 1, divided by n plus 1, plus some constant associated with cost. When I resolve all of this nonsense, what am I gonna have? 20, yeah, because 30 times 2 is, divided by 3 is, awesome. So cost equals 20 x plus 4 to the 3/2 plus k sub c. Now I use my nugget. What's my nugget? Fixed cost is $1,000. What does that mean?
When production is 0, cost is 1,000.
Yeah. When production is 0, or when x equals 0, cost equals 1,000. That's what fixed costs are. They are not tied to production. So 1,000 equals 20 times 0 plus 4 to the 3/2 plus k sub c. We can do this in our head again. 4 times 4 is 16 times 4 is 64. That's the cube taken care of. What's the square root of 64, guys? 8. What's 8 times 20? 160. And 160 plus what gives me 1,000? 840. That's okay. So now my true cost function, everybody, is what?
20 times 4 to the 3/2 plus 8.
Plus 840. Nice. And I think the rest of that you can tackle on your own. You guys know how to do revenue and how to find the nugget for revenue. That one's pretty darn straightforward, right? Same process. Nothing new here. Any questions? Where'd this one throw you, Mickey? You subtracted negative 1.5?
No, just like,
Oh,
it was
okay.
negative once and ended up being, I did the
That would
fourth
throw you,
one.
yeah. That would definitely throw
I don't
you.
know why.
Okay, groovy. Small mistake.
Yeah.
You know where you went wrong. You don't know why you did it. What were you smoking? All right, you guys, let's talk about the review. Yes. What? Yeah, they're right there. You know, they're always waiting. You can just come up and grab what you missed. It's always up here. You'll want both of those, yeah. All right. Yeah, definitely want to do this. Okay, guys. I'm going to do for you what I did for the other class, which was a pretty thorough review of chapter 10. There's a reason. Goes over an awful lot of stuff we need. Here are the 4 basic things. Where X is always production and Y is always dollars. Okay. So now we have 4 major charts instead of 3, or 4 major graphs instead of 3. Which one did I add?
P, profit,
Nope. You've known that one all along, Anne Marie.
cost.
Yes, chandelier average cost. Okay, so let me ask you guys a few questions. Can I minimize some of these? And if so, which one, or ones? Chandelier, go with your gut. Only average cost can be minimized. That's right. It's got a minimum in it, doesn't it? Okay, what can be maximized? Revenue
Revenue and profit.
and profit. Can we minimize or maximize cost? Not really. It starts at some number. That's your fixed cost, guys. That number represents your fixed cost. That's where x equals 0. Okay? But you can't minimize it, because if you did, you would just plug in 0. How to minimize costs? Don't make anything. That's how you minimize your costs, right? Okay? Can you maximize costs? Yes, build as many as you can. That's how you maximize costs. But what we can do is minimize our cost per unit. So we're looking for the most efficient, effective spot. And we do that by building an average cost function out of cost. We take cost, whatever it is, and we divide it by x. Okay? How do we minimize or maximize? What's the procedure?
Double prime.
Oh. Don't overthink it, guys. You've been doing this since 9.4. Christina, is that you? Yeah, derivative, and then we do what with it? Set it equal to 0, and then we do what with that? We solve for x. Yes, because guess what, guys? Where marginal revenue equals 0, that's the x that gives us max revenue. Where the derivative of average cost equals 0, that's the x that minimizes average cost. Where the derivative of profit equals 0, that's the x that gives us max profit. You guys with me? It is the same procedure every single time. So far, so groovy. Have you overthought these? Maybe just a tad, a skosh, a bit, sprinkle? Okay. So, what if you don't like factoring? What if you take the derivative of whatever it is and you set it equal to 0 and you just look at it and go, I don't know what the hell I'm doing? What can you do then? Yes, Chandelier. When in doubt, you guys, graph it out. So you would take whatever the derivative is, whatever the derivative happens to be, and graph it. And remember, when you're graphing derivatives, you're graphing x versus slope. So to find the place where slope is 0, it's either going to look like that, a place where it crosses the x-axis going down and to the right, or it's going to look like this, x-axis going up and to the right. So this is your derivative, whatever it happens to be. Because this point, that x value is your critical value, isn't it? That critical value is this critical value, is this critical value, is this critical value. Wherever it happens to be, wherever it crosses the x-axis, that's where your slope is 0. So how do you find this graphically using your calculator? You guys go second, calculate, which is above, trace. Okay? And you go down to 0 or zeros. I don't know if it's 0 or zeros, it doesn't really matter. And then it's going to ask you a series of 3 questions. It's gonna ask you for left bound. So you're gonna wanna drag your cursor until it's a little bit to the left, right? That's a little bit to the left of the x value you care about. Here's one a little bit to the right of the x value you care about, so here's your right bound. And then it's gonna ask you to guess. You're gonna hit enter and it's gonna guess for you. It'll converge onto this spot. You'll see the cursor land there, just like this little green star. And then it'll give you whatever x value it is. Guess what, guys? That's the x that either minimizes or maximizes, depending on what you're looking for. If it looks like this, your left bound is gonna be over here, isn't it? Because this x is to the left of the spot you care about. Your right bound is gonna be over here. This is just like dropping cars on the road and letting them crash, okay? This is straight out of chapters 9.1 and 9.2. All we're doing is we're making those little dots crash, the left bound and the right bound, over the x value where y equals 0, or slope in this case. So far, so groovy? Don't overthink it, guys. All you need is enough y value so that you see this